Alright, we are in section 4.6 and we are looking at limits at infinity and infinite limits. This is problem 273 and the problem has f of x. Oops, let me change the color of that. So we have f of x equaling x cubed over 4 minus x squared. And clearly the domain here is everything but plus and minus 2. And if we look at the graph of this rational function, it's rather interesting here. And so if we look at the actual function itself, since the denominator vanishes at -2 and +2, we expect there to be vertical asymptotes. We're going to have a vertical asymptote at -2 and another vertical asymptote at +2. Now, will there be an oblique asymptote? It appears as I tend toward the right, meaning positive infinity, or toward the left, negative infinity, the graph is approaching what looks or appears to be an oblique asymptote. Maybe something like y equals -x or something. Okay, look over here. The degree of the numerator is 3. The degree of the denominator is 2. If the degree of the numerator is exactly 1 more than the degree of the denominator, we're going to have an oblique asymptote. So let's go ahead and just verify that we have vertical asymptotes first. So look at factoring the denominator. Okay, and so here x cannot be 2 or -2, so we're going to have vertical asymptotes. X equals 2 and x equal -2. Now for the oblique asymptotes, we know we're going to have an oblique asymptote because of the degree argument. And so I'm going to go ahead and do long division here. I could do synthetic, but I'll just keep it simple here. Minus x squared plus 0x plus 4, and put plus 0x squared plus 0x plus 0. Negative x squared goes into x cubed minus x times. Minus x times minus x squared is minus x cubed. Minus x times 0x is, well, 0x. Minus x times 4 is minus 4x. And we change the sign and add. So we get 0 minus a minus 4x, which will be 4x. And there's our remainder. And here's our quotient. So this is the quotient. And here's our remainder. Well, I'll just put remain. That's going to have to be close enough. And so our function x cubed over 4 minus x squared could be rewritten as minus x plus 4x over minus x squared plus 4, or 4 minus x squared. Okay, so this part here is the oblique asymptote. So oblique asymptote is y equals -x. So our two asymptotes are y equals negative x for the oblique, and the other asymptote is at x equals 2 and also at x equal minus 2. So if I just drew the asymptotes here, scroll a little bit here, and I got a little mess there, so let me erase this here. Choose a large eraser. Alright, so if I draw a vertical asymptote at negative 2, another vertical asymptote at 2, and then another oblique asymptote at y equals negative x. And if I put the axes in, so maybe I'll make these in bold. So here's the x-axis, sorry, y-axis, and here's the x-axis here. And so on one side, over here, it'll look like this. If I pick some data points, on this side it'll look like this, and in the middle we'll do something like this. So as you can see, as x approaches 2 or minus 2, it's either going to go to positive infinity or negative infinity, depending on which side of 2. And similarly, if x approaches negative 2, it'll go to either negative infinity or positive infinity. And as x approaches the far right, meaning positive infinity, it's approaching the line y equals negative x. And as x approaches the far left, the function approaches the line y equals negative x as well. So there you have it. We've got an oblique asymptote in y equals negative x, and the two vertical asymptotes at x equals 2 and negative 2.